Good afternoon, dear students. I'm facing some technical issues while starting this Facebook Live. Okay, so I welcome you all in the first live of this page. So in this lecture, we will be discussing about chemistry, which is the important branch of chemistry. We know that chemistry is branch of chemistry which deals with study of chemicals, its applications, its properties, and different uses of chemicals, even chemical and physical changes that are studied, or these are studied in the branch of science called chemistry. Now in chemistry, if we talk in general that everything around us can be classified into two major classes, either energy or matter. We know that, see, this board is matter, human body is also matter, the pen I am holding in my hand is matter, light falling on us or the light coming out from the screen is what? Energy. So everything around us can be classified into either matter or energy. Now in this lecture we'll be specially focusing on some basic concepts of chemistry related to the matter, that is atom, molecule, element and compounds. We know that the atom is the smallest particle of a matter. When two or more atoms combine together, they give rise to the formation of molecule. Element is again the purest form of matter or pure form of matter, and compound is also a pure form of matter. So we'll be discussing these basic terms or basic concepts of chemistry one by one, so that it will be easier for you people to understand the advanced concepts of chemistry. Let's start with the first basic term, that is matter. Please tell me, what is meant by matter? What is meant by an atom? Can you please put your definition in comments? Okay. Now I am not able to see the comments properly. Okay. Okay. We'll start. Atom is the basic unit of matter that consists of three major constituents or three major subatomic particles called as nucleons and electrons. And nucleons basically includes, or the term nucleons basically includes two subatomic particles, that is neutrons and protons. We know that an atom contains three subatomic particles which we study, that is electron, proton and neutrons. In the nucleus there are neutrons and protons, and we know that atom doesn't exist independently, but there are some exceptions. We know that in chemistry or science doesn't exist without exceptions. Likewise, as atoms do not exist independently. Why? Because we know that atoms without octet or duplet, or without complete octet or duplet, are not at all stable, and therefore they do not exist independently. They combine with another element, or they either donate electrons, gain electrons or share electrons in order to complete their octet, and in order to acquire the electronic configuration as that of nearest noble gas. And here the exception cases, noble gas. Why noble gas are exceptions? Because noble gases have either 2 or 8 electrons in their outermost shell, and therefore they do not react. Like helium is having 2 electrons in its outermost shell. Neon, argon, krypton, xenon and radon, all these remaining noble gases or inert gases or 18 group elements or 0 group elements, they are having 8 electrons in their outermost shell. That means they are highly stable, and therefore they do not react, or they do not combine, or they can exist independently, unlike other or atoms of other compounds. See, here you can see the representation of an atom. In the center we can see that there are protons which are having positive charge and neutrons which are neutral, and here we can see the different shells in which electrons are continuously revolving around the nucleus. But the problem is, here you can see that the orbits or shells or energy levels are elliptical instead of having a circular shape. What is the reason? What can be the reason? Can you please tell me into the comments? Okay. I'll tell you. See, when something is revolving or when electrons are revolving around the nucleus in a circular path with certain amount of kinetic energy, what happens? While moving around the nucleus in a circular path, because of having certain kinetic energy, its path changes from circular to elliptical. So that circular atom is just, or spherical atom is just a representation of an atom, but this is the actual movement, or this is how the electrons actually move in a circular path around the nucleus. So this is, you can say that it is best representation of an atom. But if we represent an atom in this way in our books, it will be quite difficult to identify which one is first shell, which one is second shell, which one is third shell, and which one is fourth shell, and so on, right? And therefore we simply write the atom, or we simply represent an atom in a spherical shape, where we can see that first shell is there, second shell is there, third shell, fourth shell, and fifth shell. That means existence of different shells we can see independently or separately, and we can easily represent how many electrons are there in first shell, how many electrons are there in second shell, how many electrons are there in third shell, and so on, right? So this representation, as it is complicated to show the number of electrons and movement of electrons, or we can simply say number of electrons present in the shell, we cannot, or we do not represent an atom in this way, or we do not show the elliptical shape or elliptical shape of a shell or orbit. Now we know that every atom composed of nucleus and extranuclear part. Nucleus contains protons and neutrons, and extranuclear part, which is also called as shells or energy levels or orbits, they contain one or more electrons. And this one or more electrons they are in continuous movement or continuous motion around or in a circular path around a nucleus, and that circular path is called as I said, it is called as shell or energy level or orbit. And the nucleus is responsible to hold these electrons in that circular path. If hold of nucleus decreases, which is called as nuclear charge in technical terms or in the language of chemistry, if that hold decreases, or if that hold becomes zero, or if nuclear charge becomes zero, the electron may go out of the atom. That means electron, or in short, without the force between nucleus and electrons, atom will not exist. So as I said, that every atom composed of nucleus and extranuclear part, or nucleus and one or more electrons which are revolving around the nucleus in a circular path. Suppose this is a nucleus of an atom. Here we can see the nucleus is there, which contains two particles or two subatomic particles, out of which one is having positive charge and another one is having no charge. Now let's consider that this is a nucleus which consists of positively charged particle, or we can say positively charged particle is called as proton, that we know because we have studied that up to the grade 10. And this is your neutron, which is having no charge. We know that neutron is having no charge, or neutron is neutral subatomic particle. This is, suppose, your first shell is your first shell, and as we have discussed just now, that shell is having elliptical shape. This is an electron in the shell which is revolving around the nucleus, and entirely, or this species or this representation is called as an atom, where this is nucleus which contains subatomic particles. Subatomic particles contain proton and neutron. Proton is having positive charge, neutron is having no charge. There is a shell or orbit or energy level that contains an electrons, and this electron, this is how it is moving in a circular path around the nucleus. Now this electron cannot leave the path even if it decides to leave the path. Why? Because this nucleus holds the electron in that particular circular path because of having attraction between positively charged proton and negatively charged electron, and that attraction is called as nuclear charge. So this is called as an atom. Now we can say that this is representation of hydrogen atom, because we know that hydrogen is having atomic number 1. It contains 1 proton. Neutron is not there in hydrogen or first isotope or hydrogen 1 it does exist, or there is 1 neutron in hydrogen 1 2, which is also called as deuterium. Okay, so and 1 electron is there in the first shell, or you can say first orbit of hydrogen atom. This is your proton, we can say. This is your neutron, which is having no charge. Now, protons and neutrons collectively are called as nucleons. Protons and neutrons, they are called as nucleons. And electrons comes, or it is there, or it does exist in the extranuclear part, or the part of an atom other than nucleus. So these are called as nucleons. Here you can see the picture is very clear. You can take a screenshot of this screen, which will be very much helpful for you to understand the atomic structure or structure of atom and subatomic particles. Otherwise, this video will be there on the page. You can see the video, you can watch the video. One more important thing is there, or one more important property that atom possesses is 99.94% of the mass of an atom is concentrated at the or in the nucleus. That means only neutrons and protons, or majorly neutrons and protons, contribute into the mass of an atom, whereas electrons are having almost negligible mass, and therefore we can say that mass of an atom is concentrated into the nucleus or concentrated in the nucleus, whereas the extranuclear part doesn't contribute majorly or considerably or appreciably into the atomic mass of an atom. Protons have positive electric charge or positive charge, and electrons have negative electric charge, and neutrons have no electric charge. You can write it down. If you are a beginner, you can write it down that electrons are having negative charge, protons are having positive charge, and neutrons are having no charge. So what is the role of neutrons? Neutrons just contribute into the mass, and by increasing mass it tries to stabilize the atom. So we cannot say that neutron has no role in the stability of atom, or neutron has no role in an atom. Now I have one more question. Can we have a square shaped atom, or can we have a pentagonal shaped atom, or can we have a triangular shaped atom, or can we have shape of atom other than the spherical? Please tell me your answer in the comment section. I'll have a water. Sorry for the disturbance. Thank you for waiting. Why? The question was why an atom is having spherical shape, or why shell is having spherical shape instead of having other than spherical shape, that means square shape, triangular shape, hexagonal, pentagonal, etc., etc. Why? Can you please put into the comment? Okay, I'll tell you. Because spherical shape is only the shape where at every position electron will be equidistant from the nucleus, and as it is equidistant from the nucleus. Equidistant means what? It is at equal distance from the nucleus. Equal distance means what? Everywhere the distance between electron and nucleus, or electron and the protons and neutrons which are placed into the nucleus, and especially proton, is equal at every point. Okay, electrons of an atom are attracted to protons, and that electrons, or these electrons are attracted towards protons present in nucleus, are because of electromagnetic force of attraction, or we can sometimes say electrostatic force of attraction between electrons and protons. Here you can see initially these two protons, or these two positively charged particles, were very close to each other, but because of having same charge, they repel each other and they go away from each other. And here you can see that these two charges which are having opposite charges, they come close to each other. This is a GIF or animation which clearly represents that. Here you can see these two positive charges and these two negative charges, they were having same charges, and because of having same charges, they repel each other. Whereas these two charges, or these two particles, are having opposite charges, and therefore what do? They get attracted towards each other, and that attraction, here you can see how the particles with same charge move apart. That means particles having same charges, either this positive or negative, they push apart from each other, they move apart from each other, and the particles having opposite charges, this two middle one, they are having, or this middle pair is having opposite charges, and they get attracted towards each other and they come close to each other. This is because of what? Electromagnetic force of attraction, or the force of attraction between opposite charges. Here you can see the force that holds electrons around the nucleus is called as electromagnetic force. That means the same force we have mentioned over here, right? So we can simply say that electrons in the shell or orbit are hold in shell or orbit because of electromagnetic force. Okay. The protons and neutrons in the nucleus are attracted by each other. Protons and neutrons into the nucleus, they are attracted by each other. There is certain amount of attractive force, or there are certain amount of attractive force and repulsive forces in the nucleus or between the nucleons. Okay. Now, what is a molecule? Molecule, when two or more atoms combine together to complete, or so as to complete its octet or duplet, we get a new combination of two or more atoms, that is called as a molecule. Which is group of atoms exist as one species and having same properties. Suppose we are having an example H2O. Here I am having an example in this slide. Yes, this is what? C, that means carbon, hydrogen, hydrogen. This is a representation of a second member of alkane family, that is ethane. In this ethane, we can see that there are 2 carbon atoms and 6 hydrogen atoms. 2 carbon atoms are there. These are the carbon atoms. So this is your carbon atom, this is your carbon atom. 1, 2, 3, 4, 5 and 6 hydrogen atoms are there, right? So 6 hydrogen atoms are there and 2 carbon atoms are there. Then we have another molecule. Wait a second. Wait a second, I cannot see. Okay. Yes, I can move with this. Yes, here you can see we have another molecule. Hydrogen atom is there, and I'll change the color. Hydrogen atom is there. This is your oxygen atom and hydrogen atom, right? So in this we have three atoms: hydrogen, hydrogen and oxygen, right? But two hydrogen atoms and oxygen atoms, they do not have a specific or individual identity in water molecule. They are having same identity. That means they are having same properties of an element, or properties of the entire molecule is same. Here they cannot independently exist नहीं कर सकते वो. Okay, right? हाँ. Now the molecules are distinguished by ions or from ions. Ions are different. What is meant by an ion? Ion is the species having either negative charge or positive charge. Now negative and positive charge indicate what? Negative charge indicates the species which is represented by negative charge is electron rich, and the species having positive charge is electron deficient. That means it contains less number of electrons than required. Required means what? Less number of electrons than defined by or said by octet rule or duplet rule. So these are called as ions. Now ions are again of two different types. For example, here we have O2 minus, F minus, Cl minus, Br minus. These are the different ions which contain only one atom. Here we can have Al3 plus, we can have Na plus, we can have Mg2 plus, but here you can see in all these ions we have only one atom. There is another class of ions called polyatomic ion. For example, SO4 2 minus contains 4 oxygen atoms and 1 sulfur atom and 2 negative charges there. Second one is PO4 3 minus, right? Then we have another polyatomic molecule NO3 minus, that is nitrate, phosphate and sulfates, right? These ions, as they contain more than one atoms, they are called as polyatomic ions. Poly means what? Two or more than two, and atomic means atoms. That means the ion that contains more than two or more than, you can say, one atoms, and these atoms may be of same element or different element. Here we are having atoms of different elements, or sometimes we can have like O2 2 minus, which is called as peroxide ion. It is again polyatomic ion which is having 2 minus charge, and both the atoms present in O2 2 minus or peroxide ion are of oxygen, or we can say that they are of same atom, same element. Okay. So, however, the quantum physics, organic chemistry and biochemistry, here we can see, I forgot to mention the difference between ions and wait. Okay, a difference between ions and atoms. What is the difference between ions and molecules or atoms? Molecules are having no charge. For example, H2O, as we had mentioned in previous slide, C2H6, these are the molecules having no charge. That means there are no charge, and we can say that they are having either 2 or 8 electrons in their outermost shell with no charge or no excess electrons, whereas ions are having either negative charge or positive charge. And this is how molecules differ from ions. This is how molecules are different than ions. Okay. However, in quantum physics, organic chemistry and biochemistry, what we do, the term molecule is often used less strictly and also being applied for polyatomic ions, and especially in what? Sometimes in organic chemistry, in biochemistry and quantum physics. But in pure chemistry, in inorganic chemistry, see again, in organic chemistry it is very rarely used. That means the term molecule is very rarely used for the term molecule. Where is that? The term molecule is very rarely used for polyatomic ions in organic chemistry as well. Whereas in quantum chemistry and biochemistry, as they are not interested in core chemistry, they are not having any concern about the core chemistry, they can refer the polyatomic molecule as ion. But being a proper chemist or being a chemistry student, you should not refer any molecule as a polyatomic ion. So hereafter you have to remember one thing, that if we are having more than one atoms with positive charge or negative charge, should be referred as polyatomic ions and not a molecule, right? So PO4 3 minus or NO3 minus or SO4 2 minus or NH4 plus, these are the polyatomic ions. And polyatomic ions may have either negative charge, or positive charge. That means it is not like that polyatomic ions have only positive charge. Okay. So in the kinetic theory of gases, now what do you mean by kinetic theory? You must have gone through the kinetic theory. I'll give an idea about kinetic theory in short. Kinetic theory explains that two molecules are having certain amount of energy. Wait for a second. Two molecules are having certain amount of energy or kinetic energy. They are moving in any direction. We know that molecules of gas and liquids, kinetic theory of gases, that means they are applicable, or this theory is applicable for gases. See this. Gas molecules are in continuous motion. They are continuously moving from here and there. And while moving from here and there, what happens sometimes, that two gas molecules collide on each other, and if the collision of two gas molecules is effective, it gets converted into the product. It gets converted into the product, but the collision should be effective. That means the collision, number of collisions takes place in any gas molecules, because we know that gas molecules are in continuous motion. Here also around us there are many gas molecules, and all these gas molecules are in continuous motion and they are continuously colliding on each other. But the problem is, there is no formation of any new gas around us or in the air. The reason is, gas molecules do not collide on each other with sufficient amount of energy. That means they do not collide with the effective collision, or we can simply say that the collisions are not effective. Now what is meant by effective collision? Effective collision is the collision in which two gas molecules collide on each other with very high amount of energy, which is sufficient to convert these gas molecules into a particular product. This is explained by kinetic energy. Now what he says, the kinetic theory of gases, the term molecule is often used for any gaseous particle regardless of its composition. So sometimes we can consider helium, which is monoatomic gas, as a gas particle, or any gas particles or any substance which is present in gaseous state is considered as a molecule, especially in kinetic theory of gases. But again I am saying that being a chemist, what will we do? The term molecule means what? The term molecule means what? Which is group of two or more atoms. For example, we can have H2, F2, Br2, I2. These are the molecules. Now here we can see I have mentioned all the molecules with same type of atoms. And this type of molecules is called as homoatomic molecule. It is called as homoatomic. Homo stands for what? Homo means same. atoms. That means molecule contains same type of atoms. Same type of atoms. Atoms means what? Atoms of same element. We can see atoms of same element. That means if the molecule contains atoms of same element, it is called as homoatomic molecule. One more type of atom is there, depend upon another criteria, which is called as, or all these molecules as they contain only two atoms of respective element, they are called as diatomic molecules. Diatomic molecules. That means molecule containing two atoms. The molecule containing two atoms are called as diatomic molecules, right? We can have triatomic molecules, we can have tetraatomic molecules. Now, as these are the homoatomic molecules, we have another type of molecules like HCl, HBr, HI. These are the atoms with, or these are the molecules with atoms of different elements, and therefore these atoms or these molecules are called as heteroatomic. Heteroatomic molecules. Hetero means what? Hetero means different. Hetero means different. I think this is fluorescent color. Wait, let me change the color. Yes. Different. Hetero means different. That means the molecule containing atoms of different elements are called as heteroatomic molecules. For example, HCl, HBr, HI. And all these molecules or all three molecules contain only two atoms. So again, they fall under the same category, diatomic molecule. Right? These are the diatomic molecules. Hope these concepts are clear. If you are having any query or any doubt, please put it right into the comment section. Let me check the comments. Okay, we'll resume. There are no questions in the comment section. We'll continue the video. Okay. According to the definition, right? According to the definition, noble gas atoms. Yes, noble gas atoms are considered as a molecules despite of being composed of single non-bonded atoms. Why? Because they are already having, for example, noble gases helium, neon, argon, helium, neon, argon, krypton, xenon, radon. Wait a second, let me correct it. Yes, helium, neon, argon, krypton, xenon and radon. These are the noble gases which are having 2 and 8 electrons in their outermost shell. As they are having 2 and 8 electrons in their outermost shell, they are highly stable according to the octet rule, and therefore they do not react with any element, and rarely they do react. Like xenon forms compounds with xenon, Xc, or xenon with oxygen and fluorine, and sometimes with only fluorine. The reason is oxygen and fluorine, they are highly electronegative elements, or these are the atoms of highly electronegative element, and therefore they can they can force this xenon, which is noble gas, to react with them or to donate electrons to this electronegative or atoms of electronegative elements, and these are the elements whose atoms are considered as a molecule, or they are considered as a molecules. Okay, let me erase everything. Yes. Okay. The molecule may be homonuclear or heteronuclear. Means what? The molecule may contain atoms of same element or different element. For example, here you can see that I have already explained this in the same slide. They are having atoms of same element. Where is that? Yes. Oxygen or O2 molecules contain two atoms of same element, whereas water contain hydrogen, oxygen and hydrogen again, right? So this is how they are homonuclear or homoatomic and heteronuclear or heteroatomic molecules. This is how the molecules are classified into different classes. Atom and complex is connected by non-covalent bonds such as hydrogen bond or ionic bond. Hydrogen bond we generally study in intermolecular forces of attraction. Intermolecular forces. Intermolecular forces are of 5 different types, like dipole-dipole interaction, dipole-induced dipole interaction, hydrogen bonding, van der Waals force of attraction, and ion dipole interaction. So these are the 5 different types of intermolecular force of attraction, out of which hydrogen bonding is very much important, which majorly affects reactivity, melting point, and boiling point of a compound or of different compounds. And the best example of existence of hydrogen bond is water or hydrogen fluoride or ammonia. Water is having very high melting point, very high boiling point or high boiling point as compared to the hydrates of the elements from its own group or group of oxygen like H2S, H2Se. These compounds are gases at room temperature, whereas H2O, we know that it is liquid at 298 Kelvin, or we can say 25 degrees Celsius, or we can say room temperature, because this is the standard condition where we consider the physical state of any atom. Okay. So hydrogen bond or ionic bond, they are generally considered as a single molecule. That means two molecules or two atoms which are connected to each other by a ionic bonds or hydrogen bond. They are considered as a single molecule. Okay. Now classification of matter. Matter is what? It is anything that has, wait a second, it is anything that has mass and which occupies the space. That means around us, everything, as I said initially, that around us, the things which are present can be classified into two major classes, either energy or matter. Likewise, this pen is what? Matter. Human body is matter. My wristwatch is matter. This is what? The board you can see is matter. But the light which is coming out from the board is called as, or is the form of energy, or light which is falling on me from this mercury bulb or from the bulb or from sunlight is what? Energy. So matter, yes, is majorly classified into two classes: physical classification, or there are two types of classification we can say. Physical classification, usme it includes solid, liquid and gas, which are the physical states which are majorly included in our syllabus. Remaining phases of matter, or remaining what we can say physical states of matter, are not included in our syllabus as they are not well studied. Maybe after 10 years or 10 years down the line, remaining like plasma state, Bose-Einstein, this may be included in our syllabus when they are well studied. That means your son or your grandson or granddaughter may study the Bose-Einstein as well as plasma state in their syllabus. Okay, this is one classification. Another classification which is based on chemical, or which is called as chemical classification. It contains mixture. What is meant by mixture? Mixture is the kind of pure substance. It is what? Pure substance like air, tea, sugar solution is called as mixture. And the another one is, or another another class is pure substance. So again, in chemical classification we have two major classes: mixture and pure substance. And in mixture we have again two types of or two classes, homogeneous mixture and heterogeneous mixture. Homo means same, geneous means phases. So homo means the mixture that contains same phase or single phase, and heterogeneous solution is the solution which contains heterogeneous mixture is the mixture that contains two or more. We have again two particles. Pure substance means what? Which contains single type of particles which are same in their chemical nature. That means they show same chemical properties. Okay, sorry for interruption. So they contain atoms of or same type of particles which are having same chemical nature, means they are having same chemical properties. Yes. They are again classified into two major classes called compounds, and second one you can guess is an element. So compound is a substance which is obtained by union of two or more elements that we have already discussed in previous few slides, which have definite proportion. Why definite proportion is required? This word is very much important, because it can combine with, or one atom can combine with another atom in order to complete its octet or duplet. So the combination or proportion is, it must be definite. If it exceeds, we may not have 8 electrons or 2 electrons in its or in their outermost shell, and it will not follow the octet rule. And if an atom or molecule doesn't follow octet rule, it will not exist. There are some exceptions like SF6 molecule, BeCl2 molecules, but generally they combine in definite proportion by weight, and they can be decomposed by suitable chemical method. Decomposition of all compounds is possible by using different methods that we know, and that we'll discuss in the next few lectures. Then another class is an element. What is basic difference in element and compounds is, compounds contains molecules, or the basic part or fundamental unit of compounds is molecule, and fundamental unit of an element is an atom. So this is very easy to distinguish compound from an element. This is pure substance which can be neither decomposed into smaller or simpler compounds and nor built from the simple substances or simple components. That means we cannot build an atom like we cannot take one proton, one neutron, we cannot combine them to form an atom. So this is the classification of a matter. For now, we'll stop here. So thank you. Keep watching the videos and keep posting your questions in the comment section, and even you can comment in the comment section, or you can message to the same page. Thank you so much. We'll be meeting soon in next Facebook Live or the recorded lecture. Thank you so much. Thank you.